The SQL language has barely changed in 40 years because it works. That might be the most impressive compliment you can give any technology. It survived 4 decades of people trying to replace it, and it's still the default choice for new projects in 2026. So let's go through every database type that exists and figure out what each one is actually good for.
Relational database, SQL.
This is the foundation of basically everything on the internet. A relational database stores data in tables with rows and columns, connected through relationships using foreign keys. You define a schema up front. You tell the database exactly what your data looks like before you put anything in. Every row follows the same structure, no exceptions. That rigidity is the point. When you need to join data across multiple tables, users have orders, orders have items, items belong to categories, SQL handles this naturally with a single query. PostgreSQL, MySQL, SQL Server, and SQLite are the big four. PostgreSQL is the most feature-rich and is the default choice for new projects right now. MySQL powers WordPress, Shopify, and most PHP applications. SQLite is a serverless, file-based database embedded directly in your phone. You've been using SQLite every day without knowing it. The downside? Scaling. SQL databases scale vertically. You add more CPU and RAM to one machine until that machine physically can't get any bigger.
Document database. This is where NoSQL starts. Instead of tables and rows, a document database stores data as on-like objects, flexible, nested, and schemaless. You don't define the structure up front. Each document can have its own unique shape. Need to add a new field? Just add it. No migration needed. MongoDB is the king here, and it launched in 2009 as the first serious alternative to SQL. It's ideal when your data model is document-centric. Think content management systems, product catalogs, or user profiles where every entry might have slightly different attributes. The problem is that document databases can't do relational joins efficiently. If your data is fundamentally relational, shoving it into MongoDB means you'll end up writing 5 queries to do what PostgreSQL handles in 1. The verdict? PostgreSQL is the safer default in 2026 because its JSON-B support gives you document store flexibility without sacrificing joins. Key value store. The simplest database type that exists. You put in a key, you get back a value. That's it. No schema, no queries, no joins, just a massive lookup table. Redis and DynamoDB are the popular ones. Redis holds everything in memory, which makes it absurdly fast. We're talking sub-millisecond response times. It's perfect for caching, session management, and real-time analytics where speed matters more than anything else. Quick question. If you've ever wondered why a website loads certain pages instantly but others take seconds, the fast ones are probably hitting a Redis cache. The limitation is that key value stores can only answer one question. What is the value for this key? Any more complex query requires a different database. Wide column store. Think of a spreadsheet on steroids. A wide column database like Cassandra or ScyllaDB stores data in rows and columns, but unlike SQL, each row can have different columns. You can have a million rows where each one stores completely different data. It's designed for massive write throughput across distributed clusters. We're talking petabytes of data spread across hundreds of servers. Facebook built Cassandra to handle its inbox search. Apache HBase powers parts of Hadoop's big data ecosystem. The trade-off is complexity. Setting up and maintaining a wide column store requires dedicated database engineers. It's not something you install on a weekend for your side project. Graph database. This is where things get interesting. A graph database treats relationships as first-class citizens. Data is stored as nodes and edges, entities and the connections between them. Every node has a direct pointer to its adjacent nodes, which means traversing millions of connections happens through instant memory lookups instead of expensive join operations. Neo4j is the big name here. Social networks are the obvious use case. Who follows who liked what, who knows who through whom. But fraud detection is where graph databases really shine. When a bank needs to trace suspicious transactions across hundreds of connected accounts in real time, a graph database does in milliseconds what a SQL database would need minutes to compute. The downside is scalability. Graph databases are designed for single-tier architecture, which makes them hard to distribute across multiple servers. Most people, including myself, think they're incredible for specific use cases, but terrible as a general-purpose database.
Vector database. The AI-era database. Traditional databases search for exact matches. Give me the row where the name equals John. A vector database searches for similarity. It stores data as high-dimensional mathematical representations, embeddings, and finds the closest matches to a query. Pinecone and Milvus are the top choices in 2026. Every AI chatbot, recommendation engine, and semantic search system uses a vector database behind the scenes. When you ask an AI assistant a question and it pulls relevant context from a knowledge base, that's a vector similarity search happening in real time. The trend right now is that many companies are skipping standalone vector databases entirely and just adding pgvector to their existing PostgreSQL setup. One database to rule them all.
New SQL, the best of both worlds attempt. New SQL databases like CockroachDB and UgiByteDB maintain the relational data model and ACID guarantees of traditional SQL, but use a distributed architecture under the hood. From the developer's perspective, it looks like a single database. Behind the scenes, data is automatically sharded across multiple servers. It's increasingly popular for core banking and inventory systems that need perfect accuracy at massive scale. The trade-off is maturity. These systems are still younger than PostgreSQL or MySQL, and the operational tooling isn't as battle-tested. So the real answer in 2026 isn't picking one database. It's polyglot persistence, using PostgreSQL for transactions, MongoDB for content, Pinecone for AI search, and Redis for caching. The database wars are less about finding a winner and more about using the right tool for each job. Every operating system explained is on the screen. Go watch it next.